So this question is coming from May June 20, paper 3 variant 1, and we are solving part B of question 5 that appeared in the paper. Part A was simply to find the quotient and the remainder when you divide this polynomial with this divisor. You could have used either the long division or the inspection method, whichever method you are comfortable with, and find the quotient as 2x minus 1 and the remainder as 6. Now we are supposed to utilize the answers of part A and find the exact value of this integration. Now clearly you can see that this part is in the numerator and this is in the denominator. So it's clearly the format where we can simplify this polynomial fraction into its simple format with the help of quotient, remainder, and divisor. I have already explained this to you. If you have looked into the where is it? If you have looked into the key pointers over here, I have explained it to you in point H. That is exactly what I talked about. That either you can break your fraction into partial fraction or the remainder quotient format. So yeah, I'm going to use this particular thing because I am supposed to use the answers from my part 1. So integration of this is same as writing if I'm having a polynomial over divisor, this is same as writing quotient plus remainder over divisor. So let's get it into that format. So I am having my quotient as 2x minus 1, then plus remainder is 6, divisor was x square plus 3. Now I have to integrate this with respect to x and the limits are from 1 to 3. So there are multiple things, by the way, that you could have thought about whenever you are having a fraction or a division involved in the integration. You could have thought about if the denominator is in the format of a square plus b square x square. But for that, numerator has to be a constant to apply the inverse rule of the trigonometry, that is arctan or the tan inverse. So because in the numerator we are not having a constant, we are having a polynomial, this is ruled out. The second thing you can think of is if the derivative of the denominator is present in the numerator. So if I do the derivative of denominator, it is 2x. Clearly in the numerator, you are having a cubic, not a linear polynomial. That is why even the second option is ruled out. Then the third option was, can you express the given fraction into its simpler format by using either the partial fraction or the long division? Answer was yes, because that is what we have done over here. So I'm going to integrate it with respect to this, and let's see what do we end up with. What is the integration of 2x? It is going to become x square by 2, and 2 will cancel out, so it is simply x square. Integration of minus 1 will become minus x, and then the integration of 6 over x square plus 3. This is again in a fraction format where on the numerator you are having a constant and in the denominator you are having a square plus b square format. How can I say that this is a squared format? I can simply say that 3 can be written as square root of 3 square, right? So of course that is that format that I can see, and according to the rule book, here is the rule that I'm talking about that we can utilize, this one. So 1 over a square plus b square x square is same as writing 1 over b times a, then tan inverse of b over a. So let us try to implement this over here. Remember that b comes with x and a is a constant itself. So over here, this is a square root of 3, which is a, and 1 is b in our case. So this is same as writing 6 will be multiplied, and then in the denominator it is b into a. So b is 1, a is root 3, so it is root 3. And then tan inverse of bx over a. b is 1 and a was square root of 3. This is the answer that you have gotten so far. Now you have to apply the limits from 1 to 3 and we have to find the exact value of this integration. So let us plug in the value of 3 and see what do we get. For that I'm going to use my calci. What is tan inverse of 3 root 3? 3 over root 3. Let's do that. Tan inverse of 3 over root 3 comes out as pi by 3. And then I'm going to multiply this with 6 divided by root 3. And then this answer is coming out weird. So what I can do is I can just use what was tan inverse of 3 by root 3. I think it was pi by 3 or pi by 6, either of that was it. Yeah, pi by 3. So I know that it's pi by 3. And what will be the value if I substitute 3 over here? It will be 3 square 9 minus 3. So it is 6. So I have gotten 6 plus 6 root 3, that is multiplied with pi by 3. Yeah, pi by 3. And then this is subtracted by 1 minus 1, which is 0. You are simply having 6 over root 3 times tan inverse of 1 over root 3. What is tan inverse of 1 over root 3? The answer come out as pi by 6. So this is pi by 6. Now it's easy to simplify over here for us. I can just use a parenthesis instead of a square bracket so that it looks proper. So if I simplify this from here, what will I get? So 6 plus 2 over root 3 pi, and then 6 goes out. You are having pi over root 3. Now what is 2 over root 3 minus 1 over root 3? Let us try to simplify this using calculus. So this will come out as root 3 over 3 pi. So your final answer is 6 plus root 3 over 3 pi. Root 3 over 3, yeah. So this is your final answer that you got for this question. You can always conclude it by writing the final statement that therefore integration from 1 to 3 of 2x cubed minus x square plus 6x plus 3 over x square plus 3 dx is 6 plus root 3 over 3 pi. You can always confirm this using your calculator. You can just convert this into decimal first. That is answer into pi. Oops. Answer into pi plus 6. This comes out as 7.81379. Let's see if I plug all of this into my calc, see if I'm getting the same answer or not. Just a quick check. 2 alpha beta of x cube, oops, x cube, and then minus x squared. After that plus 6x, then plus 3 divided by x squared plus 3. I have to integrate from 1 to 3. Answer is 7.81379. That is exactly what we had. So you just confirmed it very quickly that this is the final answer of this question. So I hope that you have got an idea that if you are having a format of a fraction which is expressed in form of a polynomial, you can simplify it using the quotient, remainder and the divisor form and then integrate it from there.